it says it is desired to lift the wheelbarrow shown with one hand by applying a vertical force F and a twisting moment M about the axis of the handle. Estimate the magnitudes of F and M. So if you try to draw the free body diagram of this wheelbarrow, there will be this weight acting downwards, which is 1 kilonewton here, which is in this figure going down here, and there will be a normal reaction N right here. So for this problem there are two unknowns, M and F, this one and this one here. Now, so in this case your M is along the line of the handle, and if you look in terms of vectors, this can be written in two components. So if you notice, your M is right here. So if I draw M, this is your x-axis, and this one is your y-axis, and this angle right here is 15 degrees, and this one is M. So in terms of components, I can write M as M cos 15 I cap and minus M sin 15 j cap. Now for the moment balance, if I take moment about this point right here, I can write an equation where this moment M, twisting moment that is applied on the handle, plus one moment that will come because of force F, and another moment that will come because of your 1 kilonewton weight, and all of this has to be equals to 0. Now M we have already written, so it is M cos 15 I cap minus M sin 15 j cap. For the force F, we can apply the R cross F formula. So with respect to this point right here, your F is acting right here. So in X we are moving this distance, which is this right here. So I can write 1.2 I cap, and in terms of Y we are moving this distance right here, so minus 0.3 j cap, and the force is acting upwards, which is matching the direction of your k cap, so F k cap. Now for the 1 kilonewton force, the distance from this point along the x direction is 0.6 meters I cap, and the force in this case is going to be minus 1 k cap equals to 0. So now if you do the cross product, this two terms remain as it is, and this one right here will give us minus 1.2 F j cap and 0.3 F I cap. That's the second term, and the last one here will give us 0.6 j cap, and this has to be equals to 0. So now if you collect the I components together and j components together, we can write down two equations. So one is M cos 15 minus 0.3 F equals to 0, and the second one is minus F sin 15 minus 1.2 F plus 0.6 equals to 0. So if you solve these two equations, we get the value of F equals to 0.468 kilonewtons, and the value of M comes out to be 0.145 kilonewton meter. So that's the final answer.